I keep saying welcome back, but then again, that's because I mean welcome back. Thank you for coming back. We're now at this is the fifth one. This is number 4 of a series that started counting at 0 because we are computer people after all, and will continue perhaps forever. We're moving on today to building a program. We're actually going to start using some data in an XNA program, and so in this little snippet we're going to take a look at how you would actually put some variables into a program and start using them for whatever purposes. We're making a little colored light, but later on we'll use them for aliens in games and all kinds of good stuff like that. So we're building a program and we're looking at how to use data within it. The story so far, a little bit of a recap in case you couldn't wait and watch this one rather than any of the others. We have this thing called a program, which is a bunch of instructions to the computer which tell it what to do when it's actually running a game. And the game program in XNA contains two methods, one called draw and one called update. And a method is basically a bunch of behavior with a particular name. And draw draws the picture, and update updates the game engine. So the idea is that it's the draw method that puts the picture on the screen, and it's the update method that moves things around, checks for collisions, and does whatever it is that the game needs to have done when it's running. Okay. In terms of a program working with colors on the screen, in XNA, like with lots of other computer games, there are 4 values to hold a color. There's red, how much red you've got, how much green you've got, how much blue you've got, and how much transparency. The first 3 are easy. The bigger the number, the more of that color. So everything 0 and you get black, everything 255 because that's the biggest intensity you can have, everything white. If red's 255 and the rest are 0, that means you're going to get a red color. Transparency, or alpha, is slightly more complicated. That tells you how much of the color shows through. If your alpha value is 0, it means that the color is completely transparent. If the number goes up to 255, that means that it's opaque. In other words, it completely covers. If you go for about, I don't know, transparency alpha of about 120 or so, you'll get what I get when I try and paint walls, which is that I put a coat of red onto a green wall and some of the green keeps showing through. So I put another coat on and the paint has a transparency value which is less than 255, which means that whenever I paint something I can still see what's underneath, which is very annoying. So I put a second coat on and how it goes. If I could find paint with an alpha value of 255, you could call that one coat paint, I guess, because you put that on and it covers anything. So that's what alpha is all about. We know that within programs data is held in a location of a particular type. So color is held in a color variable, integers are used to hold, well, the int type can hold a number, and so on and so on. And everything else we need to know, well, XNA provides this color type and we're going to be using that to actually manipulate the colors of the lights in our program. So this is where we're headed. We're building a color changing mood light, and so we have 2 jobs to deal with. We have an update method which sets the color you want to see on the screen, and a draw method that will draw the screen with that color. Now we know from past experience too that the very first bare bones empty Visual Studio game that you get draws a cornflower blue screen, and so we want to actually change that color and make the color that's drawn part of the game engine, and then we can actually use that to make our light change over time. Right, okay, anyone got any questions? Any hands up at the back? No, you all seem fairly happy, but then again, since I can't see you, that's a fairly futile thing to say, so I'll move on. Games, right, here you go. 60 times a second a clock inside the XNA Pro system goes tick, and that tick means it's time to do stuff, and the update method is called 60 times a second to actually do that thing. So if you're playing a shoot 'em up game, that means move all the bullets and the spaceships and see if anything has crashed into anything else, and if you're playing a driving game, it means move the car along the road and update the accelerator position information and the steering wheel and all that kind of stuff. So update's job is to update the game data each time the clock ticks. The draw method kind of reads that That's a consumer of the game data, and it basically takes that data and it uses it to draw the picture. So it knows where you're looking from, where the camera is. It knows your viewpoint and what you can see, and so it provides a view of the game data for you to look at. So it's the draw method that lets you actually see stuff, and it produces the image that you get to watch. But the thing is that they're both fighting over this thing in the middle. Update is pushing information into the game data, and draw is pulling it out again. That's how it works. Simples, as that annoying commercial would say at this point. We don't have to worry about how these methods are called. It's done magically by something behind the scenes. It's tied to the way the timers in the PC work, right at the sort of original part of the game, but we don't have to worry about that. We just have to know this stuff happens, and it always happens, and we don't have to worry at all about how it happens, which is kind of nice, really. So that's how it all fits together. Data, as we've seen before, is just a pattern of bits. It doesn't actually have any meaning as far as the computer's concerned. It's just patterns of bits that happen to look like stuff and values and information and colors and whatever and sounds that we want to use. And so the computer provides this raw ability to shuffle patterns of bits around and do things with them, and we lay on top of that a bunch of software which actually makes what it does with those patterns of bits interesting and useful to us. And so we're going to actually use a piece of data to actually represent the light that we want to have in our lamp and the colors we're going to get. It's really important you get this. This is actually kind of important. Computer programs work on data. The color of the screen, your name, how many MySpace friends you've got, the things in your Amazon shopping cart, all that stuff's data. It's held in the computer and the programs actually twiddle with it. But all the time this is happening, as far as the computer's concerned, it's just patterns of bits. And so what we're going to do is we're going to actually think of or invent a method of storing a particular value we want to store in the program. If I was writing a program that kept track of your age, I'd probably find an integer to actually put that in. Integers are whole numbers, so I can be 21, 22, 23 or whatever. If I wanted to store my name, which is Rob, I could do that as a string. So string type is good for storing names, addresses, descriptions of stuff, even whole Word documents, that kind of thing. They're all held in string form. A color is held in a special color type which is provided as part of XNA, and so this is actually provided for us by the XNA framework, and it's called color with the American spelling because Microsoft is an American company. We have to live with that, I'm afraid. If you were a German or a Frenchman or any other part of the world and you were writing a program, you'd still have to use the word color in your program, so all the program constructions would end up having, unfortunately for those particular languages, to be given in the American English which Microsoft have created them in, and this is just the way computers are. So I guess you have to learn to live with it. I mean, I've looked at programs written by people who don't speak English, and they look really strange because they've picked comments and things that are all in different languages, and I can see the falls and the colours and the bits shining through, but everything else doesn't make much sense to me. So there you go. But bottom line, we're going to make a box and we're going to put colour in it, and so we'll use a colour variable type to do that. And here it is, Mr. BackColor. He's a variable with a name, and I'm saying to the system I would like to store a color value. It's going to be the color of the back of the screen, and it's going to be called BackColor. So I give the box a name, which in this case is BackColor, and I give it a type, which in this case is I'm storing colors in you, please. And so this is a piece of C#. This is that tells the C# compiler, which is looking at my program and going, hey, can I make this work? It's going to see a variable of type color, which will have the identifier, the name, BackColor. And that, once it's there, we can then start using it in our programs. And so this is effectively our game data. It's what the program will actually work on. Names of things are what's called identifiers. The compiler doesn't care. Okay, if you call it guacamole, cheese, chicken, rumbunctious, or whatever you like, don't matter. The compiler has no taste. Okay, It does have a few ground rules. If the variable is to be legal, it must start with a letter, and it must only contain letters or digits or the underscore character. And if you use a capital or a little letter, be sure to be consistent about this, because if you get it different in one part of the program, the compiler will say, ooh, ain't seen that before, and give you an error. My rule here, the bottom one, which I should have made that in red, make a name which fits the content of the variable. Don't call it guacamole unless you're keeping track of the amount of guacamole in the restaurant. Calling things silly names is mildly amusing, but it gets really irritating really quickly, because then you have to figure out, what does the variable guacamole mean? Why have I called that X35? And what's the meaning of all this cheese? Or whatever. So don't do it. Make the name fit the job, because that way it all lines up and everything makes sense. Okay. And so here you go, a little quick quiz. Which of these are legal? Height, that's not breaking any rules. 99 red balloons. Ooh, remember, that's naughty, because I said it has to start with a letter, and 99 does not. Stupid name actually isn't stupid. It's completely legal. It's stupid, but it's not legal. X is okay if you're keeping track of the X coordinate of something, that's fine. BackColor, well, all bets are off on that one, because we've already seen it and BackColor seems to work. Mystery guest with $1 in the middle might be a good password. Kind of hard to guess. I make my passwords by running words together, but the dollar kind of blows it all away, because you can't use dollar in passwords. You can use big letters, little letters, numbers and underscores, and it must start with a letter, upper or lower case. And so there you are. You know now Rob's guide to picking identifiers. And again, just pick a name that makes sense, and that'll see you go a long way, trust me. So here you go. We have a little map, if you like, of our program. There's the data, which is a box called BackColor. There's data seems to be in white in this slide. Other actions, things that are doing stuff, are in purple. So update and draw are the two things I'm thinking about at the moment. Large games, as it says here, have a whole load of game data, and quite often during the loading part of the game, when you see that bar that crawls across the screen as stuff is brought in, a lot of the game data is being set up with terrain and objects and pictures and scripts and sounds and good stuff, and all that's game data. It's all actually used by update and draw to make the game work. Okay, so here we go. There it is. New, nice, shiny color variable called BackColor, and we've declared it, and the compiler knows about it, and we're now in business. So let's start digging around in the code of the XNA program that is made for us when the new project is created. I'll do this in a second, but remember, update at the moment does nothing. Okay, nothing at all. It has this thing here called a to-do, which is effectively a little place marker that says, when you write your program, put your update logic here, and this thing leading slash blah, 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 means this is a comment. I'm just putting this in as a piece of text the compiler will ignore. So it's quite strongly signaling that whacking a piece of code in there might be a good idea. So we can do that. We can actually put a line of code in there which says set the back color, which is my game data, which holds the actual color of the screen, to a new color with 200's worth of red and 200's worth of blue, and no green. Okay, greenless. Okay, so that's my update. That's going to push information into the game world, which at the moment is just a single variable, saying, okay, I want 200 of your best red, 200 of your best blue, and no green. And remember, we've missed out the alpha thing here, so that's going to be a thick color. I'm going to do one coat paint this. Okay, so that's our producer. It's setting this color and making it that 200 value, and it's an assignment. These statements are actually called assignments. I'm working out something, making a new color, and I'm shoving it into a variable. Okay, so this thing gets transported magically into there, and it assigns a value. That's where the name really comes from. This bit here constructs the color, and it's told how much red, how much green, and how much blue. and it says there I don't want to bother with the alpha because I want one coat paint, please. So I'm leaving off the alpha value, and I'm getting myself a color which is opaque. I can leave that out if I want. So that makes me the color, and then having done that, I can then actually use my game color, my back color, in the clear method inside my draw. So now clear, rather than making everything cornflower blue, we'll use the color in our game world to actually draw the screen, and that will mean that if update starts to change the color of back color, then draw will start to draw different colors to reflect that. And I just bashed the microphone, sorry about that. Moving on. So here's a bit of demo. I've given the game away, totally blown it all, because that's what 200 gives you. So what I'm going to do now is I'm going to drift into Visual Studio, get me my buttons back, just clear away the presentation, go and find the button. You've all got Visual Studio. I'm using the Express one because it works as well as any. There'll now be a rattling noise. I had a game called Bread and Cheese. Isn't that nice? But not relevant for now. I'm going to make a new project, and I'm going to make it XNA Game Studio 3, and I'm going to call it I don't know, Game Demo 4. That sounds impressive. It implies I've done 3 others, and this is the 4th one. Let's make it work anyway. Do all the other bits and pieces. Make it a Windows game because that way it'll work the best. Click on go for it, and there'll now be a rattling noise, and you will see the game come into existence before your eyes. Now this is all the stuff that makes the game work. I'm going to actually build the whole thing from scratch. So down here I'm going to make myself a variable, and I'm going to call it BackColor. Hurrah! So that's my game world, and this will be the information which is used by update and draw to make the game work. I'm now going to actually drill gently down here. We'll find out what these methods do later. Isn't this magical? There's the update method. Aha! There's that to do that I mentioned. So I can now take this and I can replace it with BackColor, and look how Visual Studio is helping me. It says okay, equals, because that'll get it all typed in for me, equals new color, and we'll make it 200 of your best red, 200 of your best green, and no blue at all, thanks. Right, so that's given me a nice shiny new color, and after a while those annoying wavy red lines will go away because it's happy. Sometimes if it's wavy red lines are bad, but they usually go away. And rather than drawing our lovely blue screen, I'm going to make it draw BackColor instead. And having done that, this one is pushing information into my game world. This one is pulling information out of the game world and using it to draw the screen. So if I press run now, I should be rewarded by a screen of purest yellow. Perfect. I can stop the game, and just to really show what happens, I'm going to whack in 100's worth of blue. I've no idea what this color will look like. Let's run the program and find out. It's sort of icky. I'm not impressed with that at all. But there you go. You can see the color was different. The reason why it's different is that the update method, when it was called, made a different color with 100's worth of blue in it as well. So we don't see it happening because the screen doesn't change, although I'll fix that next time in the next little episode. Each time update is called, a new color is made, shoved into BackColor, and then when draw is called, that value is pulled out again and used to produce the color that appears on the screen. So I can stop that. I can go back to my slides. Look at that, wonderful. And so there you are. That's how you make mustard. 200 seems to look a bit like mustard, which is nice. Okay. So what we know so far is that we put data in our program into variables, and C# has a rule that determines what makes a valid variable, which is this must start with a letter can contain letters, numbers, or the underscore character. We make our own variables because this is how we make our program store data. And in a game, the variables are pretty much the game world. Okay, and these variables hold information which is written to by the update method and pulled out to draw the actual picture by the draw method. Okay, time for a quiz. Hello world is valid. Oh yes, I like hello world. The draw method updates the game data. Nope. The draw method is not supposed to do that. It's a consumer. It just reads stuff and uses it to draw pictures. So that one's a fib. The update method is the one that updates the game data, and that means that this particular bullet point is going to be a snap. There you go. It's green. The Xbox holds data variables on the hard disk. No. Everything is held in memory. Okay, the hard disk might be used to store stuff in different parts of the program, but as far as we're concerned, data variables live inside the program. The hard disk might store the program, but that's kind of like a stupid question, so it'll turn red. Fred and Fred are the same in C#. Well, I've already told you that they aren't, because big and little letters are different. So if you try to do that in a program, you get the compiler coming after you, and quite right too. And finally, XNA identifiers always start with X. That is just so much rubbish. What a fib. Red as red, big redness there, extremely wrong. So only two things right that time. It's a bit mean of me, but never mind. It's not a problem really, I promise. So here we go. We've actually got a look, yeah, at the colours, and the screen goes black because that means we've reached the end of this one as well. And so I should put a white screen there, shouldn't I really? Otherwise it sort of goes, whoa, the power's gone off. Anyway, next time, more stuff. Thank you very much for paying attention. Hope you've enjoyed listening again, and the next session will actually make the colours move, which will be, take it from me, it'll be amazing. Thank you.